Okay, welcome back. This is our next set of notes concerning the conservation of momentum. This is part one, explosions, but more on that later. So to start off, we are defining conservation of momentum, and the word conservation kind of gives it away a little bit, meaning we get in or we get out what we put in. So our momentum to start is going to equal the momentum at the end. In other words, our change in momentum, which is equal to our PF minus PI, is equal to 0, right? And this only applies, though, when there is no outside force applied. No outside force applied. And we're going to use conservation momentum in two scenarios. One of them is going to be collisions, which is, for example, two things going towards each other and colliding into each other, and explosions, which would be two objects moving away from each other. But this is very important. Conservation momentum comes around a lot and really helps us analyze real world problems. And it all comes back to our initial is equal to our final. And when I said here, when there's no outside force applied, this is no outside force applied to the system. And what is a system? A system is going to be defined in this class as two or more objects that are determined to be of interest. Or in other words, it's the objects we care about. So everything outside of those objects is not a part of our system. So here we have an example of an explosion, which again, an explosion we might think of as something going boom. That's not always the case. One example here is just a person jumping off a boat, right? And it fits our definition of explosion. One person's going to go, or we can see it down here. The person's going to go this way. The boat's going to go in the opposite direction. And we're just asked here, what is the total momentum of the person-boat system? And a lot of times it will specify what our objects are. Obviously, a person's not an object, but for this analysis purpose, we're treating it as such. So before the jump, right? Before the person jumps off the boat, they are going to have a mass, obviously. The boat is going to have a mass. And they're going to have an initial velocity. Now that initial velocity before they jump is going to be 0 meters per second, and the boat is also going to have 0 meters per second. So we can add up the momentum, because we're asked for total momentum of our person. I'm just going to call it P, which is MP VIP, VIP, plus the momentum of our boat, which is mb VIB. And that is going to equal, obviously, our initial velocity of our person is 0, and our initial velocity of the boat is 0, so this is all going to add up to 0. All right, and that is our total momentum. Now, after the jump, we are going to have a velocity for our person that is not 0, which is called VF is not equal to 0. And our boat is also going to have a non-zero velocity. Now, because our person boat system, there's nothing else going on with this system, we know that there is no outside force being applied. And because of that, we know that we can apply conservation momentum. And we know that the total momentum has to equal 0 after the jump. And you might say, oh, how do we know? Because this person over here might have some kind of velocity and the other one has another velocity. Well, this person is moving to the left, so they're going to have a negative velocity and therefore a negative momentum. And the boat is moving to the right, so it's going to have a positive momentum. And those are going to add to 0 because no outside force is applied. The person-boat system, the only thing happening is within that system. So there you go. Now, usually the boat will have more mass than the person. So after the person jumps, which will be moving faster, again, this is all about momentum. Momentum is our mass times our velocity. And so let's see, if we have the mass of our person, also, I'm going to bring this down too, this will help us. So we know that if we add over, the momentum of our person, we know that our boat and our person have to have the same momentum. They have to be equal. So we can rewrite this mb VFP equals mp VFP. And I'm going to explain this using some ratios. So I'm going to divide over mp, mass of our person, and divide the velocity of our boat. Okay, to both sides. This is going over here, and this one's going over here. So we have, so we're left with, these cancel. The mass of the boat over the mass of the person is equal to final velocity of the person. Is that right? Yeah, over the final velocity of the boat. Now we know that the boat has more mass than the person, so this side is going to be greater than 1. Or for now, let's just call it top heavy, right? So MB is greater than MP. The mass of our boat is greater than the mass of the person. And then we know that these two fractions are equal, or these two ratios are equal, so we know that the velocity of our person must be greater than the velocity of our boat. Okay, and I just figured that out because our top terms have to be larger than the bottom terms. All right, so the person is moving faster. Person. All right. Remember, going back to the question, which will be moving faster? And let's just do this sample problem really quickly. Again, we have a boat and mass. Person jumps from the boat with a velocity. So let's see. Again, this is conservation of momentum. So Pi equals Pf. Initially, we have the mass of our person times the velocity of our person plus the mass of our boat times the velocity of our boat. And that is going to equal 0. Because we know that our velocities are 0. This is before they jump, which is also going to equal, right? This is our initial momentum, and our final momentum is going to be, we're going to use the numbers now, 45 kilograms times -5 meters per second. They jumped off to the left, plus 60 kg times VFB. Okay. This is 2, and this is our final momentum. If I multiply these two together and add them over, I have 225 kilogram meters per second, right? That's our units for momentum. It's all good. 60 VF of our boat. So to solve for our velocity, I can divide by 60, and my velocity of my boat is going to be 3.75 meters per second, and that is a positive because the boat is moving to the right. Up there.